Hi everyone, my name is Angela and I'm a machine learning intern here at Anno. So today I'll be talking about my work with evaluating multilingual LLM performance on the languages team. So if you just tuned into my teammate Aria's presentation on personalized chatbots, my presentation will dive more specifically into the language evaluation leaderboard portion of it. Why do we want to evaluate multilingual LLMs? Well, our goal is to identify the model with the best performance for each language and directly implement that into our chatbot so users can be confident that they're always using the best model. So, by testing each model on a standardized benchmark dataset, we can rank them based on their performance and compare fine tuned versus zero shot models. We also want to make this information available for users to view, so we've created a leaderboard page for users to view all of this information on. Overall, we feel like evaluation ensures quality and usability across linguistic boundaries and increases accessibility to our product for clients all around the world. So one of the evaluation metrics that we're using to assess the performance of our models is BLUE. So this is a widely used metric to evaluate the quality of machine translated text. And it works by calculating the number of n-grams, which are sequences of 1 to 4 words in the candidate text, and how much they match with the reference text. Also, to avoid unfairly favoring short translations, Blue also incorporates a brevity penalty for translations that are significantly shorter than the reference texts. So the final score returned is between 0 and 1, with a higher score indicating better performance. And you can see the full calculation of the Blue score below here. So as you can see, the first portion incorporates the brevity penalty, and the second portion incorporates the n-gram overlap. So BERT score is our second evaluation metric, and it leverages contextual embeddings from BERT to measure the semantic similarity between the candidate and reference text. So the reason why we might prefer this over a more traditional metric like BLUE is because BERT is a language model trained on masked language modeling and next sentence prediction. And masked language modeling is where some text in a sentence is randomly masked, and the model tries to predict the original text based on the surrounding context, which enforces this bidirectional context where the model is able to understand the relationship between both words in both directions. And so that provides more context and it goes beyond just calculating the n-gram overlap. Next sentence prediction is where two spans of text are given, and the model predicts whether or not the sentences appear sequentially. So, unlike Blue, which relies mostly on that n-gram overlap that I described earlier, BERT score focuses on semantic similarity, and it means that it can recognize paraphrases and extract a contextual understanding, even when the words are slightly different. So, there are three scores that are returned: precision, recall, and F1. F1 is taken as the final score because it's a more balanced measure of both the precision and recall score. And you can see specifically how this process of computing BERT score works in this diagram below. There are many open source multilingual benchmark datasets out there, but here are some that we found to be the most relevant for our purposes. So the one that we've run all of our benchmarks on so far is Flores 200, which is a translation benchmark that was created by Meta, and it has parallel sentences in over 200 languages. So, in order to evaluate our leaderboard on it, we ran the dev test set for all 5 of our languages, and each dev test set contains around 1,000 different sentences, and they're all parallel across all 200 languages in this Flores 200 dataset. So we found this to have the widest coverage with over 200 languages, and it's fairly standardized. But we'd also like to run benchmarks using other data sets that we found, such as XQuad, which was created by Google, and it's suitable for evaluating cross-lingual Q&A performance. There's also Tidy, which is a Q&A dataset that covers around 11 typologically diverse languages. And what makes this dataset unique is that it contains linguistic characteristics beyond those found in the English language. and so it provides a more diverse data set for us to benchmark on. And finally, there's MLQA, which is a highly parallel benchmark dataset for evaluating cross-lingual Q&A performance across 7 different languages. So there are many high-quality benchmark datasets out there. We've currently been using Flores 200 just because that has the widest coverage, but we definitely want to expand in including these other benchmark datasets to see how our metrics and evaluations may differ and if some models may perform better on one benchmark versus another. So some of the tools and libraries that we used were NLTK, which is a Python library that's commonly used for NLP tasks. And for our purposes, we use the translate blue score module, which contains the sentence blue function for calculating the blue score. There's also an option in this to adjust the weights given to different lengths of n-grams. And because the sentences in the Flores 200 dataset tended to be shorter, we it gave more weight to shorter n-grams, and giving more weight to shorter n-grams ultimately yielded higher scores. So as we continue to benchmark on different data sets that might have shorter or longer sentences, we would also want to adjust the weights that are given to different lengths of n-grams. BERT score is another Python library that was used to compute the second metric, and BERT score was the class that was used to compute the BERT score, and it contained the score method, which computes those 3 metrics that I mentioned earlier: precision, recall, and F1. We also use the Hugging Face Transformers library, which contained tools such as BERT Tokenizer to tokenize the text in a way that the BERT model would take as an input, and BERT model was the pre-trained neural network. So moving on to some of our findings, we included both Blue and BERT score for 5 different languages. So that includes Spanish, Japanese, Arabic, Chinese, and Korean. And we also ranked 3 different zero-shot models: GPT-4o, Claude 3.5 Sonnet, and Gemini 2.5 Flash. So as you can see here, this is on our page. If you go to the evaluation leaderboard, you can see that at the top we have the Spanish and how it performs in Blue and BERT score. And then if you scroll down, there's also Japanese, Arabic, Chinese, and Korean. And so if you take a look at the results from our leaderboard, you can see that GPT-4o pretty consistently ranked the highest among all the languages apart from Korean, which Claude 3.5 actually ranked the highest. And then so for our future steps, we would take these findings and implement them into the chatbots feature on our website. And when the user toggles between different languages on the chatbot, the best performing model is automatically being used. So that takes a lot of the cognitive load off of the user so they don't have to kind of think or go between which model might be the best for their purposes. And then they're also able to refer to this leaderboard if they want some more context as to why one model might be being used instead of another. So some of the challenges we encountered along the way were that the first one that we encountered was that there were kind of inconsistent blue scores across some of the different languages. So if you look here on the right, you can see that there's Spanish blue score and then Korean blue score. And for Spanish, it's ranking around zero point 0.5, whereas for Korean, it's below 0.01. And so we noticed a pattern that languages that use that Latin alphabet, like Spanish or English, were ranking in the zero point 0.5 range, while non alphabetic languages such as Korean, Japanese, and Chinese were ranking below 0.01. And so once we noticed this pattern, we realized that because non-alphabetic languages are tokenized differently, we needed to use a language-specific tokenizer. And so our solution was to use Fugashi, Jieba, and Korean NLPY, which are specifically made to tokenize Japanese, Chinese, and Korean text respectively. And so once we did that, we realized and we noticed that the non-alphabetic languages were now ranking in the zero point 0.5 range, so matching that of the Latin alphabet languages. Another challenge that we ran into was that we were finding lower benchmark scores for some of our fine-tuned models. So as you can see here on the right, our fine-tuned GPT 4.1 model scores in third place. And our solution to this is to do some more targeted fine-tuning to focus on specific error patterns, whether that includes certain topics or conjugation or syntactic structures. So we plan on using k-means algorithm, which iteratively assigns data points to the nearest centroid or the mean of the cluster, and it essentially recalculates the centroids until the data points no longer shift clusters. And so we're able to form natural patterns or sentence structures into these groups. And then um, this can help drive data efficient improvements by identifying examples where the model might perform more poorly. And then after that, we can subsequently train on high impact subsets to create increased performance in those areas. And then finally, for future directions, we want to expand the selection of languages that we offer and also the selection of models that we offer. So we currently have 5 languages, as I mentioned before, but we would also like to include more, such as French, Italian, and more. And this way we can increase accessibility to a wider client base. And we'd also like to see user submitted models added to the leaderboard. So we have currently a submit model to leaderboard API in progress. And so after we fully implement that, we'd like to see more users submit their own models and see how they rank within the models that we currently have on our leaderboard. And we'd also like to see more popular zero shot models added to the leaderboard as well, such as Llama. We'd also like to implement the model submission API, as I mentioned before, and this will allow users to easily submit their own models to add to the leaderboard. So for more information on this, you can tune into Josh Chang's presentation. It's tomorrow at 5:40, and so he has been implementing that API that will allow users to easily submit their models and then be displayed on the current model leaderboard. Finally, we want to focus on more targeted fine tuning based on our evaluation score findings. So, as I mentioned before, using that k means clustering algorithm to identify which parts the model is performing poorly and then generating more synthetic data to improve the model in those parts. And hopefully that way we're able to kind of take what we find from the evaluation and from the leaderboard and actually use it to improve models. And so we hope that users who also submit their model to the leaderboard can find out what their specific model is scoring and then use that information to help them complete targeted fine tuning as well. Yeah, so that's kind of a basic overview of what I've been working on and what the languages team has been working on. I hope that you find this helpful and that you tune into our other presentations. Thank you.